Welcome to the DIY Honda Garage channel. This presentation will provide a comprehensive troubleshooting guide for the Diagnostic Trouble Code DTC C1243-14, specifically indicating a low voltage signal from the pressure sensor 2 in the 2022 Honda Civic. The error refers to an abnormal reading from the brake booster pressure sensor 2, which plays a critical role in the proper functioning of the braking system by measuring pressure levels. If the output voltage from this sensor is below a specified threshold, the electric vacuum pump control unit recognizes this as an abnormal condition and stores the corresponding DTC. Understanding the components involved and the implications of this error is crucial for diagnosing and resolving the issue effectively. Ensuring safe vehicle operation. The DTC C1243-14 indicates a signaling issue with the brake booster pressure sensor 2 that results in a low voltage reading. The brake booster pressure sensor 2 is a crucial component located near the brake booster, measuring the pressure to assist in brake operation. Its primary function is to provide essential data to the electric vacuum pump control unit, facilitating effective brake performance. When this sensor fails or the signal sent is below the acceptable voltage limit, the control unit identifies this as a malfunction. This error profoundly affects braking efficiency, since an underperforming brake system could lead to serious safety concerns. Regular checks of this sensor and its wiring are essential in maintaining optimal vehicle performance and safety. Several potential causes can lead to the activation of DTC C1243-14. Firstly, wiring issues can often lead to discrepancies in voltage readings. Damaged or corroded wires may interrupt the signal between the sensor and the control unit. Secondly, the brake booster pressure sensor 2 itself may be malfunctioning. Wear and tear over time or physical damage can impair its function. Additionally, the electric vacuum pump control unit might be faulty, failing to interpret the correct signals from the sensor and thus registering an error. Each of these causes needs careful investigation, as they can all affect the sensor's output voltage, leading to compromised vehicle safety and performance. When DTC C1243-14 is triggered, several symptoms may arise, indicating issues with braking performance. A primary symptom is difficulty in braking. The vehicle may take longer to stop or feel less responsive. Drivers may also notice a warning indicator light on the dashboard, alerting them to a potential issue within the braking system. Moreover, an erratic response from the electric vacuum pump control unit could occur, affecting the vehicle's braking efficiency. These symptoms not only compromise safety, but also suggest the need for immediate diagnostic assessment to prevent further complications and ensure the reliability of the vehicle's braking system. The first step in troubleshooting DTC C1243-14 involves a systematic confirmation procedure. Begin by turning the vehicle's ignition to the on position, which activates various electrical systems, including the brake booster pressure sensor. Afterward, switch to the off mode and wait for at least 2 seconds before turning the vehicle back to the on position. This procedure helps reset the sensor system and may provide consistent readouts in subsequent tests. Such confirmation steps are critical as they help in identifying transient issues and preparing the system for further diagnostics, ensuring that any error codes are up to date and accurate. The second troubleshooting step focuses on inspecting the sensor 2 supply circuit, which is vital for the functioning of the brake booster pressure sensor 2. Conduct an open wire inspection to check for any discontinuities that could cause signal failures. The expected resistance in the wiring should be less than 1 ohm, indicating a healthy electrical connection. If resistance is higher, it may suggest damaged wiring or poor connections. Detailed attention to the wiring integrity is essential because a compromised power supply can directly lead to low voltage signals and malfunctions indicated by the DTC. By ensuring that the wiring remains intact and well connected, you can eliminate common faults contributing to the error. In the third step, the focus shifts to the sensor 2 signal circuit, which carries the output from the brake booster pressure sensor to the electric vacuum pump control unit. An essential part of this diagnosis is to verify that the signal circuit is not shorted to ground, as a short would lead to incorrect voltage levels being detected. If the circuit is found to be shorted, this could significantly mislead the control unit, resulting in erroneous performance. Ensuring continuity in the signal circuit while preventing any grounding issues is crucial, as it allows the sensor to transmit accurate data for effective braking functionality. If the circuit is intact, attention may shift back to the sensor itself, which could be at fault if the signal remains problematic. Once all previous troubleshooting steps have been conducted and any necessary repairs or replacements have been made, it's time for final verification. Begin the process by clearing the Diagnostic Trouble Code, DTC, from the vehicle's onboard computer system. Following the clearing of the DTC, perform a drive test under various conditions to ensure that the vehicle operates smoothly. During this drive test, carefully monitor for any signs of DTC reoccurrence. If the code reappears, further investigation may be necessary. Establishing the reliability of the repair ensures that the braking system functions as intended, providing confidence in vehicle safety and performance following the diagnosis and repair processes. To prevent future occurrences of DTC C1243-14, it's essential to implement a preventive maintenance strategy. Routine checks of the brake booster pressure sensor 2 can catch issues before they escalate. Additionally, regularly inspecting wiring connections for signs of wear, corrosion, or damage can further reduce the risk of electrical faults leading to erroneous signals. Routine brake system inspections will also help ensure that all components, including the electric vacuum pump control unit, are functioning properly. Such proactive measures are key to maintaining vehicle safety and performance, reducing the risk of unexpected errors and enhancing the longevity of the braking system. In conclusion, understanding the implications of DTC C1243-14 and effectively troubleshooting this error is vital for maintaining the safety and operational standards of the Honda Civic 2022+. A thorough inspection process, beginning from confirming the ignition state through to checking the supply and signal circuits, ensures any underlying issues are addressed. Recognizing potential causes, such as wiring problems or sensor malfunctions, helps pin down the root of the issue. Additionally, implementing preventive maintenance strategies can significantly lower the chances of reoccurrence. By adhering to these guidelines, vehicle owners can ensure reliable braking performance and safety in their day-to-day driving experiences. Please like and subscribe to the channel. See you next